Today, we're going to talk about soft body physics in Unity. And I started investigating this because I'm making a game. My game is inspired by the game Kicks, in which you were to fill or claim a percentage of the screen while trying to avoid these squiggly things that went around in the empty space in the middle. So you had this little marker that you shot across the screen to create a new line, and by that creating a new square. And you couldn't touch the things that flew around, otherwise you die. So I went with this inspiration, but I wanted to evolve it a bit. So I figured, what if you created circles instead? What would that be like? So I built that, a prototype, and it wasn't really engaging or immersive enough, I felt. So I figured, what if the circles were affected by gravity? So like, what if they fell down? And that didn't really do it as well. So I went a bit further and thought, what if the circles were squishy? And that actually made it a lot more interesting. So to make this happen, I had to investigate soft body physics in Unity. And it turns out there's nothing built in for this. So in Unity 4, which is the previous version, there was a thing called interactive cloth that you could use. It was made for making objects like flags or clothes or stuff like that, but it was very computationally expensive, and therefore it was removed in Unity 5, which is the current version. And I don't think it would have worked very well for 2D games or 2D objects, so that wouldn't do. There's also now a thing called vertex motion, which wasn't around when I started out with this. It's a shader-based solution, which means that it runs on the GPU, which is a lot faster than running on the CPU. I haven't tried it, so I don't know if it works with 2D physics or how well it works. The demos look really cool, but I haven't tried it out. So since this wasn't around, I figured, how hard could it be? And what could go wrong? So I'm actually going to show the demo of this. So I'll quit out of this presentation and go for Unity. So I created a demo for this. So this contains only the blobs that I have been working on. This is a very simple scene. It has some boundaries that are colliders so that the blobs can't escape. And the blobs themselves are a prefab with some components on them, just normal 2D physics components, so a rigid body for the mass, and then I have a script that I wrote called blob, which is the main part of this. Then it has a quad and a mesh render, and attached to this is a shader that just, instead of drawing a square, it draws a circle. So it's not much to it. They could be square as well, it will work, but I wanted circles. So then I have two other scripts here. So I have a grow script, or a click to spawn script. So when I click in the game area, I will spawn a blob, and while I press the button, it will grow. So it's just for demoing purposes. It has a physics material attached to it, which just lowers the friction a bit, because otherwise they sort of stick to each other, which isn't as fun. So I'll just start this and you'll see what it looks like. There we go. So if I click and press, I spawn a blob. Looks like this, and then I can spawn multiple ones. And as you see, when they collide, they sort of squish together a bit, and you can make a lot of them. They'll sort of interact, so wobble around like this. And if we look closer at one of these, we can see some things. So first of all, they're no longer just one object. Actually, this was a particularly bad one to select. I'll look at this one instead. because for the green one you can't see these green circles. So as we can see here, it has a bunch of child objects. So the script, the blob script, when it starts, it first of all, it actually has like 3 stages. So the first thing it does is it creates all of these child objects, and these are reference points, and all of them have a collider. So these are the green circles you can see. So all of these are colliders that do not collide with each other, but they do collide with the environment. After those are set up, the quad that is initially attached to the blob is split up into multiple small quads. And a quad is a three-dimensional rectangle with just one side, which is what we use to draw 2D graphics on in Unity. So as you can see here, these consist of a series of quads like this. And the reason this is done is to have more vertices, which is every point in the quad. And we want more vertices because we want more precision in the rendering. So as you can see here, for something like the green circle up here, it looks pretty regular. It looks like a square basically. But if we look at one of these that are sort of squished together, we can see that the vertices are like they've changed position, and that is how the blob changes form. So the quads are split up into smaller quads, and after that, in the third stage, what happens is every vertex is mapped to every reference point in this circle here. So I record the initial distance from a vertex to every reference point, and then I attach a weight to that. So the longer it is, the lower the weight. So the reference points closest to a vertex will affect the vertex the most, because on every update cycle, or for every frame we render, I check where all the reference points are at after the physics system has done what it does. So like it moves all the reference points according to what it touches, and then I check the positions of the reference points and readjust the vertices after that. So that's what's sort of creating this like this motion in the rendering. Yeah, so that's the demo of just the blobs, and so this is sort of a hacky way of solving it. Right now, like this runs fine on on the latest iPhone, but on like an iPod Touch, if you create like a bunch of small blobs or like fill the screen with a bunch of small blobs, that becomes very heavy for the physics engine to calculate, or actually not the physics engine, but rather the algorithm that maps the physical objects to the vertices and adjusts the vertices, because that runs on the CPU. So it's quite heavy. I think there's room for a lot of optimization. For example, like as you can see here, the small blobs have just as many vertices as the big ones. So one optimization could be to scale the number of vertices with the size of the blob. So a small one would need fewer because it's smaller in its rendering. So you wouldn't see the imprecision in that. So this is what the demo looks like, and now I can show you what the actual game looks like. It has some tweaks to it. So let's open a project. There we go. So this one, this game is called Fill, because you're supposed to fill the screen with circles, and I'll just play it for you. So instead of these squiggly things in quick kicks, we have balls that bounce around instead, like this, and I can click to spawn these blobs, and as you see, when I do, this meter goes up, so that's how you can see how far you've gotten. And for the art style in this game, I've created a bunch of palettes with colors. that will change when you go to the new round. And also when you go to the new round, there will be another ball. So eventually, like the screen will be full of these small balls, and you can't touch them while you're growing a blob, because then it will explode like that. And you have, from the beginning you have 3 lives. Now I have only 2 left. And as you can see, my score is constantly ticking downwards. So to save my score, I have to complete this level as fast as possible. So the score functions both as a score and a timer. So whenever I come to a new round, the timer ups a lot. So the faster I can win these rounds, the better the score I'll have. So as you can see, all these have different colors. And now I game over. So yeah, that's basically it. Thanks very much.